Imagine switching on your fan from the beach or checking your home's temperature while stuck in a traffic. That's the magic of IoT, the Internet of Things. It's what powers smartwatches, smart fridges, and self-driving cars. In this final project of our Smart Home Kit series, we'll bring it all together, making your ESP cloud connected and smarter than ever. Now let's talk about how all of this actually works and why setting up the IoT platform is the first and most important step. What we're doing here is connecting our ESP32 microcontroller to the Buni IoT platform, as you can see in my screen, which acts as a bridge between your hardware and the internet. With this setup, your devices can do four powerful things. Number one, send data to the cloud. Number two, receive commands from anywhere. When you toggle a switch or set a timer on the Buni dashboard, the command is sent down to your ESP32. That's how we are able to turn on a fan, toggle LEDs, or change RGB colors even if we are miles away. Number three, automate based on condition. You can set rules like if temperature exceeds 30 degrees Celsius, turn the fan on. This automation doesn't need you to be involved. It works 24/7 based on live sensor data. And number four, trigger notification and action. The IoT platform allows you to trigger actions like sending an SMS or blinking an LED if something unusual is detected, like a sudden spike in humidity. So for you to get started, you can go to smarthomeiot.angazelimu.com and you'll be directed to this dashboard. So I already have an account. I can just log in. And the first page that you'll see are your projects. So for you, you might have like a blank screen now, but no worries, we'll get there. So this Buni IoT platform, you can do several things. You can create a project, you can read tutorials on how to go about creating your own projects, and forum, just an interaction platform between other developers. So if you go to create projects, you are allowed to select the components that you're dealing with. So if you're dealing with an LED, fan, a smoke sensor, a PR sensor, a keypad, then here's where you're able to select. Then you're needed to create a decent to have a decent project name for your project. So maybe I can say my first project. Then you are required to give a very good description. So I can say this is a project that automates operations in my house. And then you can choose the type of notification that you want. Do you want SMSs, email? So I'll go with both. And I can pick several sensors. Let me just pick all of them and then we'll see what to expect. So remember, the IoT platform is just creating a digital twin of whatever hardware you have there. So make sure that you have all this hardware before you get started. So buying the Buni Smart Home Kit will help you to have all of this. So you can just click create and your project will be ready for access. So I can go to my projects. So remember how we called our projects. You should be able to see it here. So it's my first project. Click on that. It will direct you to this page where you can now monitor things. So you can see I created I chose DHT when I was setting up and other sensors. So you'll have widgets for all of that. And then you are given like a unique ID, an API key that helps you to connect your hardware with this platform. Just click here So you can see we're having the other widgets. So an LDR is just a light sensor. You can close that. LED. For LEDs, you can blink them, you can toggle them, you can set timers. For rain sensor, you can set a threshold, you can set a timer. So rain sensor normally automates the closure of windows. So when it's raining, it will do that for you. RGB LED, you can blink it, you can toggle, you can do a cool project on color picker. You can also set intervals, smoke sensors, you can set a threshold. Yeah, so all the widgets, all the components that we pick will have the widgets for monitoring purposes.
We'll get started with the first project, which is blinking the onboard LED. So head over to your smart home platform. We can start with creating a project. So I'll give it a name. And a description. Like that, and then I'll choose board notification. So for the components, we'll only need the LED. Then we can create the project. Head over to the project that has been created and click on the name. It will open up and you'll be given the credentials. So the most important credential is the API key, and I'll show you how we use it. So for this onboard LED, we'll do a bunch of operations and you'll see in a few. So let me open the code file. Okay, the next step is to configure the code file. The code file is included in the description as a link that you can access, and it has several files. The most important one is the README that will help you understand the project. So as you said, we'll be blinking our LED remotely using the smart home platform, and it's defined in this particular README file. Also, you can read to understand more on the files. So you need to configure your secret.h file, the Wi-Fi name and your Wi-Fi password together with the API key. So go to the secret.h file and then put your Wi-Fi credentials. What you'll need to do is to take that API key from the platform and change it here. Always make sure that your API key is not exposed to people. Yeah, it's your own secret, so you need to hide your API key. And then we can upload the code. So I've already connected my ESP32. Yeah, so we'll do the uploading. Now, after uploading our code, we can start testing the Buni smart home platform. Yeah, so under the toggling section, you'll see the LED state is off, and you can see also the video of the ESP32 has the LED off. So I'll just click on, and then you'll notice that the onboard LED goes blue. Then we can switch it off once again. So you can remotely monitor your devices using this particular platform. Let's try a different thing. We can go to blinking. So we want that LED to blink, and you can set here an interval in terms of microsecond. So 1000 microseconds is equivalent to 1 second. Let me submit that. So we have set the blink interval to 1 second. Let's make sure that our LED is on so that we can see the effect. Notice that the LED starts blinking at the rate of 1 second. Okay, let's go to the set timer section. So this can be used to schedule when your lights will go on and off. So under the on category, all you need to do is to set the timer to go on at a particular point in time. Maybe you want your lights to go on tomorrow morning at 7 a.m. You can just do that, and if you want it to go on only for one day, you can schedule one occurrence. If you want repeated day, then you can do so. So you can click on submit and it will update the records with that. So when 7 a.m. reaches, then the timer will go on. Also, you can turn it off at a time that you want. Maybe you want your light to go off tomorrow, now at 7 p.m. with one occurrence, so you can submit. Yes, so that's how you basically do. Let's create the fun project. Go back to the smart home platform, click on create project. Let's give it a name. I'll also give it a description. I'll pick both notifications. We can take DHT and fun and create the project. Let's access the project. We can pick this API key and open the code file. Remember, I've included this code file in the description. The first step is to go to the README, learn about the project. So it's written here in detail. So this project is designed to monitor room temperature and humidity levels using a DHT sensor, send data to the platform, and control a fan based on temperature readings. You need a DHT, an OLED screen, and fan. So the next step is to configure our secret file. We'll use the API key that we've just taken from the platform to ensure that the hardware is connected. The next step is to upload the code. So once your code is uploaded, data will start streaming into the platform. So you can see the values here are incrementing. We're monitoring humidity, temperature, together with the timestamp. So all of these have threshold. For humidity, the threshold is at 80. For temperature, is at 25. What means with the threshold is that if conditions goes above this particular value, then something will happen. And for this particular project, it's basically the control of a fan. As you can see in the video, the fan mounted on the ESP32 microcontroller is off, meaning that the threshold has not been exceeded. So what we'll do, we'll try to put a reading that is lower than the current value. So we can try something like 21 degrees Celsius. Let me maintain humidity threshold to 80 and submit, and we'll see that the fan will start rotating. Notice if I put another value that is higher than the readings, the fan will go off. As you can see. So the fan goes on to cool the room, which is basically automation. So you can also go to metrics where you can see a plot of your data. Let's pick on line graph. So whenever the readings are accessed in the platform, they'll be plotted there. A line graph is more visually appealing, so you can track temperature fluctuation in your environment. You can also export data in form of an Excel file or CSV file.